solve the same question using the scalar methods, that is conservation of mechanical energy principle. Let's do it. Over here this is 10 kg block, this 5 kg block. Initially both of them they are stationary, this is also not rotating. So it has terms that is, like potential energy, kinetic energy, potential energy, that is gravitational potential energy, and it's a linear kinetic energy, not rotational kinetic energy. This is only going to rotate, but let's say we write over here P and K. Over here we have losses, and losses they are going to be equal to gains. Let's take one by one. Potential energy of this. What is the loss or gain? This has gone from here to here, so height has been lost, so potential energy has been lost. Loss of potential energy is mgh, 10 into 10 into 2, that is loss. Please understand, we are only interested in the changes in potential energy and kinetic energies. We are not interested in the absolute value of potential energy. So we know, we have done it earlier also when we had done the chapter work, energy and power. Over there we said that is whenever the height increases, it means the potential energy has increased. If there is a loss of height, it means potential energy has reduced. If the velocity increases, kinetic energy increases. If the velocity reduces, kinetic energy reduces. Over here the velocity is 0, and this is going to strike this with the velocity v. So from 0 to v the velocity has increased, so that's why there is a gain of kinetic energy is half into 10 into v square. Both these terms they have been dealt with. Initially it may be at any height, but if this block goes by 2 meters, so this block also goes with 2 meters up. So gain, we are not interested in the absolute height of this from here to here. We are interested in what is the gain of height, what is the gain in potential energy. So when it goes from here to here 2 meters, so it gains a height of 2 meters. If I have 100 bucks in my pocket and after some time someone puts 10 more bucks, so during this time I have a benefit, I have a gain of 10 bucks, not 110 bucks. Similarly, when its body goes from here to here, then the gain of height is not this much. The gain of height is only this much of 2 meters. So gain of potential of this is 5 gh. 5 into g we are taking as 10 meters per second square only for the ease of calculation, into h. Kinetic energy. If the velocity over here is 0, the velocity over here is also 0. If this is going to strike the velocity v at this instant, this is also going to have velocity v. So gain of kinetic energy, half into 5 into v square. Now, both these terms they have been dealt with. Now, coming to potential energy of this. This height, or the height of center of mass of this pulley is neither moved up or moved down. So potential energy change is 0. So delta P is equal to 0. Kinetic energy, what kind of kinetic energy? That is rotational kinetic energy. Rotational kinetic energy, what we know, that is equal to half I omega square. So this again, initially it was not rotating, now it is rotating, is half I is 10 into omega square. We also know that is this velocity is v. So this point also has velocity v, rather this point also has a velocity v in this direction. So, but this point P is right now is having a velocity that is also situated on the circle. This is also in circular motion at this instant. So v is equal to r omega is very much applicable. V is equal to r is 1 into omega. So we replace over here, that is omega is v by 1. So we can put it over here, v by 1 square, that is v square. Now we have losses equal to gains, that is 10 into 10 into 2 is equal to half 10 plus 5 plus 10, that is 25 v square, plus 5 into 10, 10 into 10, 100. So this is 200 minus 100. 100 is equal to half into 25 into v square. So this is 200 by 25 is equal to v square. So v comes out to be, so this is v square comes out to be 8, or v comes out to be 2 root 2 meter per second. We get the same answer as we have got by the dynamic principles.